Hello, testing, testing. Alright, mic volume seems good, I think. Bam. Hello, good morning, or afternoon, or evening, wherever you are. What's up? Today, we're doing more Google interview questions. Immortal says, today is my birthday. Oh, happy birthday, Immortal. Hope you're having a good one. Okay. Well, this is kind of awkward. So, I'm signed out of my Leetcode account on. This is Microsoft Edge, meaning I have no access to Premium right now. Oh well. Studying and watching your stream. Hey, nice. Alright, well. Well, this is kind of awkward. I have been signed out of my Microsoft Edge account, which means I no longer have access to my brother's Leetcode Premium at the moment. That's okay though. We can review some Google interview questions then. Today will be review day. Let's look at some questions that got us in the past. So, first up is Leetcode 2663. Leetcode 2663. Lexicographically smallest string. Okay. A string is beautiful if it consists of the first K letters of the English alphabet. Okay. It does not contain any substring of length 2 or more, which is a palindrome. It does not contain any substring of length 2 or more, which is a palindrome. Oh, hey Gibri, by the way, hello. Return the lexicographically smallest string of length n, which is larger than s and is beautiful. If there is no such string, return an empty string. Okay. Oh wait, actually, let me see if I can... Okay, no, I still can't sign it like that. Rip. Okay, so it consists of the first K letters of the English alphabet. You are given a beautiful string S of length n and positive integer k. Return the lexicographically smallest string of length n, which is larger than s and is beautiful. Okay, I remember this sentence confused me a lot too. Return the lexicographically smallest string of length n. So this is like not talking about length, this is lexicographically. And is also lexicographically larger than s, meaning it comes after s, doesn't it? A string A is lexicographically larger than string B of the same length if in the first position where A and B differ, A has a character strictly larger than the corresponding character in B. Okay, so for example, ABCD is lexicographically larger than ABCC. Yeah, because the first position they differ is at the fourth character and D is greater than C. Okay, so example 1, ABCZ, K is equal to 26. Okay. So meaning you can use all the letters of the alphabet, right? Oh, I kind of remember this, so you want to increment it very minimally, right? lexicographically smallest string of length n, which is larger than s and beautiful. Yeah, the next smallest string after this one. And you can't have any palindromes. Length 2 or more, which is a palindrome. Does not contain any substring of length 2 or more, which is a palindrome. Okay, so... Okay, I have to think about this. Go to Java. We're given ABCZ, right? So at first glance, we want to increment Z, but there's no bigger letter than Z. So we loop around and we put this to A, and we sort of do a carryover. So ABDA, I guess. Yeah, ABDA, that makes sense. DC, okay, that makes sense to me. It does not contain any substring of length 2 or more, which is a palindrome. In what cases would we get a palindrome? Let me try to recreate a palindrome. ABCB. So at first glance, we would put it to ABCC. Yeah, ABCC. So how do we return the lexicographically smallest string, which is larger than s? So we have to increment this minimally. Do we just put this to D? Yeah, okay. What if we have some really annoying cases like AB? Can we do a carryover and also ADCZ, I guess? So at first glance, we would do AB, DC, A, we do the carryover, so it becomes D, and we look over, and it's like, oh. Alright, there's a palindrome, so we put this to E, A, B, D, E, A. Is that what we do? Hold on. That's not it, is it? You could do A, B, D, B. Oh, wait. There's no way we're getting around the palindrome like this. Z. So we have to do... Oh no, A, B, D, E, A? Yeah, A, B, D, E, A. We have no other choice, right? A, B, D, C, Z, A, B, D, D, A. Yeah, what's the smallest one that could possibly be bigger than this? Well, we cannot just increment A to B because the palindrome still exists, so we have to increment this D somehow, minimally, so it's A, B, D, E, A. Ooh, okay. How do we check for other palindromes? Ooh, this is tricky. Wait, so every time I increment a letter, do I have to make sure that it's not out of bounds as well? Or like it's not a palindrome too? Because what if I have like this too? What if this becomes an E? Oh no. Okay. Okay, I think it's starting to come back to me. So pseudocode. Okay, so basically we add 1 to all the letters, right? Oh dang, how do we do this? So first step is to add 1 to the characters at the end and carry over if necessary. That's what we do, right? Okay, should we just try that? How do we represent this in a loop? Dang, am I actually stumped here? My mind is just blanking out. Z. You know what? Maybe it'll help if I just start coding. That's what some recruiters told me. Okay, so okay, it might be easier to split this into a character string. So we'll do characters is equal to character array is equal to s dot to character array. Is this how you do it? Java string to character array to char array. Okay, that's exactly how you do it. So what we do now is s dot characters dot length. So we want to add the last character, right? So the last index will be characters dot length minus 1 is equal to No, we just do plus plus, right? Yeah, okay. And then for now, let's return characters dot. How do you convert a character array to a string? Java character array to a string. String dot value of? String dot value of, got you, okay. String dot value of characters, okay. This should be the most simple case. We're gonna have to take care of all the carryovers later, but this is just a sanity check right now. ABCZ, of course we go out of bounds. DD, okay. Shoharu says hi. Hello Shoharu, how you doing? I'm doing good. Yeah. What do I even say? I've been doing well on Pokemon Go. I caught a Mimikyu recently, and it's a good Mimikyu too. Yeah. Although now I'm very struggling on this this hard problem. Okay. So while let's do an index, right? Int I is equal to characters.length minus 1 characters I plus plus. Okay, so while what? Let's do while I is inbounds is less than characters. Yeah, how you doing, Shoharu? Characters length Okay, so let's do the case where we have to carry over. So if okay, how do we know that it needs to carry over? If the current character is equal to 1 over our k thing, right? So if the current character at I, characters I, is equal to Shoharu says, I will watch only for a moment to ask how you are because I'm sick right now. Oh, get well soon, Shoharu. That's pretty rough. Characters I is equal to what? So I have to check if it's out of bounds. How do I do that? A plus K, maybe? Okay, so the first K letter, so what happens if K is 2? Then A plus 2 will be equal to C. So if it's equal to C, then we need to... Yeah, okay. If it's equal to C, then we need to carry over. Okay, that makes sense. So then we set the current character back to A, and then we do the carryover. I plus plus. Yeah, okay, that makes sense. And then we'll do character I, or I minus minus. Yeah, okay. And if you cannot increment I, like I is out of bounds, if I is less than 0, meaning it's out of bounds, what do we return if... Okay, return an empty string. Got you. So in the case that we need to carry over, but there is no carryover, we return an empty string. Got you. And then character I plus plus. Okay, that should be our carryover case. We should have more cases though. Okay, let's run this. Characters, oh, it's characters. I plus plus. Let's do an else statement. Else I plus plus. Yeah, if there's nothing we need to do, then I plus plus, and eventually it will go out of bounds and will return true. Okay, I think that's what we'll do. Nice, okay. Case 1 is now correct. Case 2 is not. Our output is DD. So we have to do palindrome detection now. Okay. Nice, we're on the right track then. Right, okay. So the logic so far is we'll just carry over until we don't need to carry over anymore, and then we'll search for palindromes. Yeah, okay. Very cool. Else if... Okay, time to search for palindromes. How do we do this? How do I search for a palindrome? So if chars I... Oh, okay. I need to check if things are inbounds too. So if I minus 1, excuse me, is greater than or equal to 0, and the current character is equal to the character directly to its left, I minus 1, then it's a palindrome. Okay. So this is one thing. That's for the two-step palindrome. Okay, the string we're given is already guaranteed to be beautiful, right? So there's probably no... Is there a chance for a bigger palindrome? Probably not, right? Yeah, probably not. Yeah, there's no shot at that. Also, if 2 characters in a row already aren't a palindrome, then you can't form a palindrome with it either. So yeah, okay, we should be good. And, okay, we gotta be careful here. This is for the case where, this is for like, for example, if we have A, B, C, A, I guess, and we increment B, this is for this case. Yeah. Okay. We need to check for palindromes of 3 characters length. If I minus 2 is greater than or equal to 0, meaning it's inbounds, and characters I is equal to characters I minus 2, then that means we have a palindrome of length 3. Okay. Palindrome. Of course, if we have a palindrome, we increment the letter on the rightmost, not the leftmost, because we want to make a minimal change lexicographically. So, characters I plus plus. Okay. Okay, where do we go from here? Do we need to I minus minus again? I minus minus. Check for more palindromes. Well, yeah, what do we do here? We don't need to check for more palindromes, right? So if I have like this, ooh, okay, and I increment B, it becomes A, B, C, C. That's still a palindrome. Dang it, that's still a palindrome. Characters I plus plus. Huh. I minus minus seems like a good option here because we'll go for here, right? And we'll be like, okay, no palindrome here. Go back to here. Yes, palindrome, so we increment it to D. And then we go back to here. Like, okay, that's fine. We go back to here. Okay, that's fine. Okay, that seems like a good option to me. Let's try submitting this, I guess. Wait, what happens in this case, the DC case? DC case. And we can only use the first 4 letters, so A, B, C, D. Okay. So we increment this to D. Okay, everything's good so far. It definitely does not go through here. So else if there's a palindrome, right? Characters plus plus, so it becomes E minus minus. It goes through here. That should be fine, so I plus plus. Then it goes through. Then it goes to here. If characters I is out of bounds, yes, it's out of bounds. Then we reset this to A, yeah. And I minus minus. Yeah. And then characters I plus plus. So this now becomes E as well. Okay, and then we loop back to here once again. and we return, yeah, we try to carry over again and returns this. Okay, I have hope for this. Please work. No. Output is still DD. Why is it DD? Oh. Or it's not an and. Let's go, it worked. Let's freaking go. Let's freaking go. This problem is still really hard for me. It took me so long to derive it by myself. So once again, Gabriel says, good job, I see hard, my brain shuts down. Hey, thanks, Gabriel. So once again, this step is do carryovers. You have a palindrome and an LSI++. Oh, we did it. Cool. Let's do another problem. Let's do 1526. Leetcode 1526. Minimum number of increments on subarrays to form a target array. Oh, I can't remember this one. Man, why are we all doing hard problems? Well, I guess that's why I wrote them down, huh? They're all hard problems. You are given an integer array target. Marissa says, hello, Chet. I currently don't have time because of other stuff, but I will leave a like and keep the window open so it counts as a view. Dang, that's so nice of you. Thanks so much for the support, Marissa. I appreciate. Dang, that's actually so nice of you. You have an integer array initial of the same size as target, with all elements initially zeros, okay? In one operation, you can choose any subarray from initial and increment each value by 1. Any subarray. Return the minimum number of operations to form a target array from initial. The test cases are generated so that the answer fits in a 32-bit integer. Okay. Yeah, okay. So for this one, for example, we can increment from 0 to 4, and we get all 1s, and then we increment this, and then we increment just the 2 to get 1, 2, 3, 2, 1. Okay. And then we have 3, 1, 1, 2. So we increment everything first, then increment this side, this side, this side, this side, one by one. Okay. There was a trick to this, right? Let's copy the example over here. See what we can do with it. Okay, so for 1 over here, there's an iterative solution, right? So for 1 over here, we're like, okay, how do we get 1 here? We just increment it by 1. Sure. How do we get 2 over here? We're like, okay, so we could have continued the subarray from 1 over here. Yeah, 2, this spot could have been covered by the subarray increment starting from here as well. So 2 minus 1 is 1, so we only had to increment this by 1. Because we could have used the subarray increment from 1 to... Yeah, okay. And then we look at 3 over here. Like how many more subarray increments from the previous do we need? So we could extend the increment from 2 all the way from here, the previous. So all we need is one more than that. So 1, 2. It's like, okay. Could the subarray increment from before have covered me? Yes, it could have. So it's 0. The previous is bigger than me. And the same applies to 1. Okay. So it's 3, 3, 3. Yeah, 3. Cool. Let's try this example. I believe this iterative solution should work. So once again, you start from beginning to end. We're like, how the heck do we get a 3 here? We need to increment it 3 times by 1 each time. What happens to 1 here? It should be covered by, the increments from before, 3. The increments from before could extend all the way here. So it's 0, 0, 2. It's like, okay, could the increments from before affect me? At most, 1 could affect 2. So 2 minus 1 is 1. Okay, I think I understand what the algorithm should be then. Okay. So we need to keep track of what previous is equal to 0. And then 4. Should we keep track? Is there a use for an index at this point? For every int num in target array. What do you do here? Oh, we need a operation count to int op count is equal to 0. So if the current number is greater than the previous number, then that means operation count plus equals num minus the previous. Because we can only use so much from, we can only extend the previous subarray increments so far. Yeah. Okay, and then else this is the case where the current number is greater than or less than the previous, meaning the previous increments could have covered me. Yeah, okay. And then we return operation count. Oh, I need to update my previous too. Previous is equal to the num, and then we keep incrementing. I feel like that's how it works. Accepted. Very cool. Hey, let's go. It worked. This algorithm is still pretty tricky to think about. Okay. Yeah, no need to simulate the actual thing, right? That would take a long time. I also need to make a note to myself. To have my brother log into his Leetcode again. Okay. Should we do another one? Leetcode 42. Kuni Panda says hello. Hi Kuni Panda, how's it going? Leetcode 42. Trapping rainwater. Is this a premium question? Oh, it's not. Oh, we did this last time, didn't we? Oh. Should we do this right now? We did this so recently, I don't think it's useful to do this another time. Because it's so recent. Fine. I'll probably do this one, but I won't mark it down as complete on my notebook. I'll still mark it down for review in the future. Okay. Hakuni Panda, how you doing today? Trapping rainwater. Given n non-negative integers representing an elevation map, where the width of each bar is 1, compute how much water it can trap after raining. Okay, so what is, let's take an arbitrary spot here. Let's take this spot. What's the maximum rainwater it can trap? So the strategy is, you look on the left side, what's the max here? It's 2. Okay, you look on the right side, what's the max here? It's 3. We take the minimum of the maximums, which is 2. So that's the max water level here. And you subtract the ground level, so it's 1. Yeah, compute how much water it can trap after raining. What's the water level here? Well, I don't know, here, 2. Max over here is 1. Hold on. It includes myself, right? It's definitely not 1 here. Oh. Should it be inclusive? 2 minus 2. Oh. So on the left it'll be 2. 2. Oh, okay. So it doesn't matter if the max is myself, because 2 minus 2 is 0. It's 0 regardless. Alright, that makes sense. Okay, so I feel like what we have to do then is to compute the local maximum going from the left, local maximum going from the right, and then for each spot, take the min of the maximums at my spot, subtract the ground level, and that's how much water I can trap at this spot. Okay, that's what we'll do then. Int local left, local max left is equal to new int height dot length. And then the maximums from the right, local max right is equal to new int height dot length. Very nice. Okay, time to compute the local maximum. So for int I is equal to 0. This is the maximum left maxes. I is less than local max left dot length I plus plus. Okay. We'll do int current max is equal to 0 so far. They can't exceed 0, right? Yeah, okay. They can be greater than or equal to 0. So first we will update our max. Oh, wait. What happens? Local max left is equal to max at I. Would it make sense to update our max at the end after we update it max. Max is equal to math.max of the current max and local max, well, the height at I. I think it also makes sense to update the max after we go through an index, right? Because then we don't include me at the index, my height. Yeah, I think that makes sense. So for example, here 2, the max would be 1 and 3. We would take the min, which is 1, and since 1 is less than 2, it doesn't matter. There's no water here. Okay, that makes sense to me. Next, we need to get the right maxes. Right maxes, max gets reset to 0. Code Life says Java. Oh shoot, it's freaking Code Life. Hello, nice to meet you. I saw your stream with, oh no, I forgot her name. It's so bad. The astrophysics VTuber. That was pretty cool. It was pretty exciting to see more VTubers do Leetcode. Yeah, you do Python, right? Python is pretty optimal for Leetcode, I hear, because you can do a lot in relatively few lines of code. Yeah, how you doing, Code Life? Oh, it's Z. Oh, that's what you call her, Z. Where int I is equal to local max right dot length minus 1. So we do this greater than or equal to 0 because we're going backwards. We're starting from the end, going to the start. So I minus minus. Heck yes. Hey Code Life, I don't know if you're allowed to say, are you currently like a student studying CS? I saw on your channel you were studying some like ML or NLP stuff. Code Life says, I'm horrible at this, you seem to be doing alright. Oh, nah, today is review day. I'm reviewing all the problems that have gotten me in the past for Google interview questions. So if I look like I know what I'm doing, it's because I've already done it before. Yeah, today was a unexpected review day because I actually used my brother's Leetcode account because he has premium, but today it got auto signed out of Microsoft Edge. So I'm just doing a impromptu review day. Code Life says, nope, not a student, I make money. Oh dang, you're still learning while you're making money. It's pretty cool. Dang, you're actually a real life software engineer. Very cool. Okay, so local max right is equal to the current max. Else not else. Afterwards you update the max with the current height. Okay, that should make sense. Colab says, but I still will study. I want to prep for a PhD someday. Oh, a PhD. That's pretty hardcore. I actually battled a PhD student the other day for Leetcode. He did really well. He got like 4 of 4 correct. It was pretty impressive. I think I'm going to do a sanity check right now. I'm going to print out all of my local maximums. Make sure I'm actually doing this right. So arrays dot toString local max left. And then local max right. When in doubt, print stuff out, say circuit. And then for now, I'm going to return a int, which is -1. Okay, sanity check. Why is this not correct? Oh, arrays.toString. If I may ask, are you a student, kiddo? Wow, you call me a kiddo? No, I'm not a student. I graduated. I'm currently job hunting. So I'm using streaming as motivation to, practice every day because I suck at I suck at interviews. So nope, not a student. Graduated, hunting for job. Okay, is this correct? 0, 1. Okay. 1, 2, 2, 2, 3, 3, 3. Okay. Over here is okay. Sure. It's basically this example, right? 0, 1, 0, 2. So over here, the maximums would be 1 and 3. We would take 1, which is the minimum. Yeah, okay. I think it works. What about here? 0. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Okay. We would take a 2 over here, over 3. Yeah, okay. I think it works. Kolai says, good luck. Interviews are not fun. I hope you become a gatherer soon. Currently hunter. Yeah, interviews are really hard. Man, they make you go through so many stages. It's kind of annoying. Or I don't know if you want to hear any like sad interview stories or whatever. So for this, we just need to go through int water will set to 0, and then we'll go through every single index from start to end, and then add up all the waters, don't we? Yeah, okay, so int I is equal to 0, I is less than or equal to less than or equal to what? Height length I plus plus. Okay, how do we calculate the water level here? Int water level is equal to math.min, the local maximum at the left and the local maximum on the right. I and local max right I. Okay, and the current land height is int land height, land level is equal to height I. Okay. I feel like we're on the right track here. So if water level is greater than your land level, then water plus equals what? The land water level minus the land level. I feel like we're really close. And then we return the water. Bam. Index 12 out of bounds. Oh, less than. We're so close, I can feel it. Oh, let's go. Let's freaking go. Heck yes. Oh, okay. CoLife says, I like your hair. Oh, thank you. Oh yeah, I can give some interview stories. Yeah, my hair is like sparkly, almost like glittery, spacey. Give me medium sad, not too sad. Oh, what interview stories do I have that are just medium sad? Let me think about that for a second. Oh, okay. I have one. Hmm. Should I talk about this? Hmm. Should I think about a fun one? Hmm. Alright, so man, there's so many to choose from. Medium sad ones. Too sad if there's no mid. Okay. Hmm. Okay, so there's this one time I was interviewing for a medium-sized company, and let's see, I literally passed all of their interview stages, right? The recruiter came back to me and they were like, "Yo, you did really well on all your interview stages, and most likely we're gonna give you an offer next week." And man, he really made it sound really promising. He really made it sound like yeah, I'm gonna get an interview or like an offer next week, and that they really like me and stuff. And then 3 days later, on Monday, he called me back and he was like, yeah, update. So apparently, two of you guys passed all the interview stages, and there's like one main position that you guys are competing for. So, ideally, we want to hire both of you. Like, maybe there's another position somewhere that one of you guys can take if one of you doesn't make it or whatever. So I'm like, wait a minute. So it's starting to sound like I maybe will get an offer, but I maybe will also not get an offer. So it all just depends on, apparently team matching at this point. And then fast forward, there's another call like a week later, and he's like, okay, we're still discussing whether we want you, like, and I forgot what he said, but basically for each progressive call, he sounded less and less certain that I was actually gonna have an offer, even though he began with, "We're probably gonna give you an offer next week," and then like on the fourth call, he was like, "Yeah, sorry, we ended up going with the other person." So it was like, no position for me. So yeah, I literally passed every single interview stage, every single one. There was like, I don't know, 6 interview rounds or something. One initial Leetcode, one behavioral, one system design, 3 more Leetcode, and then like, yeah, it all came down to team matching. But man, what I really don't like is that they really made it sound like I was gonna get an offer in the beginning. Like they were freaking dangling it in front of me. They were freaking dangling it in front of me. They were like, yeah, we're gonna give you one next week. And then for each progressive call, it sounded less and less likely I was gonna get one. So yeah, I was so pumped too. That was like the first time I actually passed all the interview rounds for any one company. This was like 2 to 3 weeks ago, I think. Yeah. Yeah, I was low-key pretty mean. They were freaking dangling the offer in front of me, I felt like. And they were like slowly retracting it for every single call. Like, ah, frick. Oh well. It was a good learning experience though. Yeah. It was actually, yeah, passing all the interview rounds is pretty rewarding too. Yeah, I feel like it was a very big milestone for me too, because yeah, it gave me a lot of hope, to be honest, that if I can pass, these interview rounds, I may be able to do, or like pass more in the future, Thanks Code Lab for the encouragement. I appreciate. Yeah, I feel like that's the saddest interview story so far. We got so far. Alright. I think that is all the LeetCode questions I'm going to do today then. I literally did 3 hard problems today. Though it's all review. Next up, I'm going to do some system design study. Give me a moment while I get the book out. I'm probably just going to do a really short reading. Yeah. So, this is my system design study screen. Well, bam. Okay. So this is the part of the stream where I'll probably be a little bit more silent and not as talkative because I'm literally just taking notes and reading. Yeah, I literally have a physical notebook here. The display. Code Life says, I'll also do 30 minutes of studying while lurking. Good luck for both of us. Oh yeah, good luck on your studying too. Okay. So we were learning how to design Google Drive last time. Your eyes are very Coraline bad mother vibes. Oh yeah. Bad mother was like button eyes, right? I actually have eyes behind these eyes. They're just like voids. Okay. It is kind of chilly in this room. I'm gonna go put on a jacket. Give me one moment. No, the door between the houses. Huh, I remember I watched Coraline on a plane once. I really enjoyed it. Coraline. Bad Mother is indeed very scary, especially if you're a little kid watching it. Bad Mother. Oh wait, I forgot her eyes are like this. They actually like connect. The eyebrows connect to the bottom thing. Oh my god. Wait, my bottom eyes are like that. I don't know about the glasses though. Cool. Beldam. Is that her name? Alright. Okay, so we were at the part right before... Oh, her name is the Beldam. I see. Okay, we were at the part right before the design deep dive. Okay, so apparently this is the general system design architecture of Google Drive. Okay, so the workflow for uploading a file onto Google Drive is like the user. So for all non-API, or sorry, all other API calls, you go through the load balancer and the API servers. Okay, so for uploading a file onto Google Drive, you apparently go through some block servers, which cuts up the file into multiple blocks, you know, into smaller file sizes, and then it can process them in parallel, and then upload them into cloud storage, which is like Amazon S3, AWS S3. Yeah, and then we also have a cold storage option, which is apparently for files that are not commonly retrieved, but we still want to store them. So I think I looked it up last time. Cold storage is like, it's really cheap for storage, but fetching is computationally really expensive and and also sometimes financially expensive too. Okay, and if you want to, and I guess I imagine if the cloud storage is done with the upload, it goes to the load balancer to the servers, and then it updates the metadata to mark it as complete as well. Okay, and then besides uploading to the metadata, the servers also go through a third-party notification service that notifies the user whenever a file is uploaded or edited, and then if the user is not online, it moves it to a backup queue to process in the future. Right, that makes sense. And then when the user tries to retrieve a file, it goes to the load balancer, to the API servers. I guess the cloud storage goes to the load balancer to the API servers again, and then it returns the file to the user. Okay, very cool. Okay, deep design dive. I think I'll just read a little deep design dive, and then we'll call it a day today. Solaris says, I may have overcomplicated that one. Oh, the previous problem I did? Let me see what you did. Oh. Is this your solution? It looks really simple. No, it's on the bottom left. Oh, this one, okay. Oh. Oh, you have 2 pointers, left, right, ms. Wait, what's ms.pop? ms.pend. ms stands for monotonic stack. Oh, okay. So it maintains in a certain order, huh? CodeLife says, hey, you haven't linked your Twitch anywhere, why? Oh. I'm a YouTube main. Yeah, you're fine to watch me on Twitch, but I focus mainly on YouTube. That's my favorite platform, I guess, so my socials kind of point one way to YouTube. Yeah. Do you prefer Twitch or watching people on Twitch? Holy, I don't know if you guys can hear it, but it's like pouring outside. The rain. Bet you can't guess where I live. Oh. Okay, block servers. For large files that are updated regularly. Delta sync. When a file is modified, only modified blocks are synced instead of the whole file using a sync algorithm. Oh, okay. I love rain. It rained last night as well. Oh. Can y'all hear this? It's actually pouring out. Yeah, some rain is good. Applying compression on blocks can significantly reduce the data size. Thus, blocks are compressed using compression algorithms depending on file size, file types. Oh, you guys can't hear a thing. All right. That's good then. I think my mic is one of those types that only catch really close sounds. In our system, block servers do the heavy lifting work for uploading files. Block servers process files passed from clients by splitting a file into blocks, compressing each block, and encrypting them. I see. Okay, so only the modified blocks are transferred. I see. So if you have like a, I don't know, PDF file, I guess, or like a Google Doc, and you modify only this, I don't know, last page, you only need to upload the blocks for the last page. No need to touch the other blocks for the other pages. That's kind of neat. Okay. And each block is compressed and encrypted. Got you. Okay. Got it. Okay. That's really neat. Okay. High consistency requirements. Our system requires strong consistency by default. It is unacceptable for a file to be shown differently by different clients at the same time. The system needs to provide strong consistency for metadata cache and database layers. We must ensure the following: data in cache replicas and the master is consistent. Invalidate caches on database. Write to ensure cache and database hold the same value. Okay, makes sense. Achieving strong consistency in a relational database is easy because it maintains the ACID properties. Okay. However, NoSQL databases do not support ACID properties by default. Oh yeah, I heard this recently too. I think my brother was talking about this. Maybe I should do a review on what ACID is. What the heck is ACID? ACID. Programming. Okay, so it's like a property that only some Okay, so it's a property held by some, guaranteed by some databases, I guess. Not all, like NoSQL. Atomicity. Okay, so each statement in a transaction is treated as a single unit. Either the entire statement is executed or none of it is executed. Oh, okay. So it's the all or nothing thing. Okay. All or nothing. And this refers to all statements in a transaction. Consistency. Transactions only make changes to tables in predefined, predictable ways. Corruption or errors in your data do not create unintended consequences for the integrity of your table. changes to tables in predefined, predictable ways. Okay. Isolation of the transactions ensures that the concurrent transactions don't interfere with or affect one another. Okay. Each request can occur as though they were occurring one by one, even though they're actually occurring simultaneously. Okay. Durability ensures that changes to your data made by successfully executed transactions will be saved, even in the event of system failure. All right. Database that supports banking transactions might include a rule stating that can never be a negative number. So it can't violate the rules or constraints placed on the data. Isolation. So no concurrent transactions, basically, on the same resource. A transaction that finishes the change is guaranteed to be made. Yeah, okay. Okay, good to know. ACID properties must be programmatically incorporated in synchronization logic. In our design, we choose relational databases because the ACID is natively supported. All right. So, okay. So, TLDR, if you want easy ACID, choose relational databases. Okay. Metadata database. We have the files, the workspace ID, user block, file version, file ID. Okay, sure. Okay, so the upload flow. Okay, 2 requests are sent in parallel. Add file metadata. This is just purely upload, right? Upload the file from scratch. Okay. So we add the file metadata and upload the file to cloud storage. Both requests originate from client 1. Okay. Add the file metadata. It goes directly to the API servers. In our metadata DB, it marks it as pending. And then after it's done, it notifies the user of the change. Okay, that makes sense. Client 1, it uploads the file to the block servers. Block servers chop it up and upload it to cloud storage. And then it updates it makes another call to our API servers. Which also updates the metadata DB again to mark it as uploaded. And then notification service notifies of the change back to client 2. All right. Oh, hey Marissa, welcome back. Oh yeah, Marissa, how's your wrist doing? You hurt it recently, right? Or your hand? Oh no, your hand got worse? No. Man, I wonder what happened to it. I hope it gets better. Is there a path for it to get better? I hope there is. If client A is online, okay, so this is the download flow. When a file is added or edited somewhere. So there's two ways. There's a notification service, or if the client is offline, data will be saved to the cache. When the offline client is online again, it pulls the latest changes. Data will be saved to the cache, okay? When the offline client is online again, it pulls the latest changes. Go, okay, makes sense. Notification service. Oh, okay, so client 2 represents another user, doesn't it? Okay, got you. So client 2, it goes to the API servers to get the changes specifically. It gets the changes from the metadata DB, returns the changes from the metadata DB. Okay, oh, okay. So then it kind of just returns the blocks, right? I see. And then they download the blocks from the block servers. Block servers go to cloud storage, download the blocks. Oh, cool. So you only download the blocks that are relevant. Cool. Marissa, it's probably too much writing and stuff. I mean, the last time I had it, it was because I wrote for like 2 hours straight. Oof. Writing for 2 hours straight. That's pretty rough, man. Maybe, I don't know, I'm not a doctor. I don't know how to fix a wrist. Sounds like maybe overusage? Well, I hope you can rest your hand a lot and hopefully it gets better. API servers call metadata DB to fetch metadata of the changes. This is pretty cool. So you only need to pull the blocks that have changed. Okay. Notification service allows data to be transferred to clients as events happen. WebSocket. Yeah, just a bunch of third-party stuff, huh? We read about WebSocket previously. It's kind of like HTTP on steroids, huh? But it allows bi-directional communication, like for a chat app. You can write with both hands. At least I can write with both hands, so it's not that big of a problem, I guess. Dang, you're ambidextrous. Cola says, I'm gonna go now. Nice meeting you, chat. Good luck. Oh, thank you. Have a nice day, Code Life. Nice meeting you too. I'm probably gonna go soon, to be honest. I said I was just gonna read just a little bit of this design. Oh, your time zone might be very late right now. I see. Good night, man. Save storage space. Have a nice day too. Okay, to support file version history and ensure reliability, multiple versions of the same file are stored across multiple data centers. Yeah, it'll probably take up a bunch of storage space. The duplicate data blocks. Eliminating redundant blocks at the account level is an easy way to save space. 2 blocks are identical if they have the same hash value. The duplicate data blocks. You mean, like, I don't know, if someone is storing 100 blank pages, I guess, is this what it's talking about? Like if someone is storing 100 blank pages or identical blocks, all those blocks are going to be the same. They're just blank pages. Okay. But what are the chances of that happening though? And it looks like my phone is almost out of battery, so I'll have to go soon. Adopt an intelligent data backup strategy. Set a limit. We can set a limit for the number of versions to store. Okay, so the oldest ones will be dropped. Keep valuable versions only. Some files may be edited frequently. Okay. We could limit the number of saved versions to give more weight to recent versions. Okay. Moving infrequently used data to cold storage. Cold data is the data that has not been active for months or years. Cold storage like Amazon S3 Glacier is much cheaper than S3. I'm really curious, how much do you actually save based on cold storage? AWS Glacier versus AWS S3 costs. Oh, here. Dang. Glacier is 0.00099 cents per gigabyte per month. I imagine that's really slow, right? Glacier takes 5 hours to retrieve data. How much does S3 cost? 1 cent per gigabyte. Okay. Yeah, you do save a lot. Let's say this is a 1 here. Yeah, you do save a lot, I guess. Okay. Man, we're actually done reading this. Failure handling. Load balance failure. The secondary could become active. Okay. Block server failure. Other servers pick up unfinished or pending jobs. Cloud storage failure. If files are not available in one region, they can be fetched from different regions. Okay. API server failure. Yeah, just do another API server with load balancer. Cache servers. Cache is replicated multiple times. Metadata DB. Master is down, use a slave. Slave is down, use another slave. Notification service. Over 1 million connections are open per machine. So clients must reconnect to a different server. Okay, offline backup queue failure. Queues are replicated multiple times and one queue fails. Consumers of the queue may need to resubscribe to the backup queue. Okay. And we're done. We'll probably read this and finish it up last time or next time. Okay. I feel like I'm done for today. Yeah. We reviewed 3 hard problems. Yeah. And we got through the Google Drive design, which is really nice. Very cool. Okay. I think I will call it a day today. Thank you to everyone who came. Dude, it was so cool of CodeLab to come on and say hi. She actually stayed for a really long time too. Thank you, Marissa, for coming too. Oh, can I raid anyone right now? I'm always talking about raiding people. Oh frick, Brime is on right now. Let's go raid Brime. It's fine. Alright, thank you everyone for coming. Bye guys. Oh yeah. Me and Norino are doing another battle on Saturday. It's a rematch. I think this is the first. Is this the first rematch? Yeah, probably. Remember we tied 4-4 last time? It was pretty sick.